Good evening. This was the problem we were solving in the class, and this particular given problem, has to be solved using Kmaps. So the size of the Kmap is determined by the formula 2 power n, right? So where n is the number of variables. So we are given with 3 variables a, b, and c. So this is 2 power 3, which is equal to 8. So the size of the Kmap is now having 8 cells. So we can draw a simple Kmap using 8 cells like this. Right. So we can write this given variables here a, b, and c. Right. So can give different colors to this. A can be 0, A can be 1, and B can be 0, and C can be 0, and B can be 0, C can be 1, and B can be 1, and B can be 1, C can be 1, and B can be 1, and C can be 0. So according to the given problem, you have to fill the map. So we start with 0, and second is 2, and this is 4, and we have a 5, and the last one is 6, right? So you know how to fill the Kmap using from the given question. So we can start doing the groupings now. So choose the biggest group. So this one is these two can be grouped together. So we can name them group 1, right? So from the group 1, we can see that A is jumping from 0 to 1. So we cannot take the value of A. So you can see B and C now. B is compared with this cell. So B is 0 here, and B is now 1, right? So B is changing its value from 0 to 1. So we cannot take the value of B. So we can now look for C. So this is C. C is 0 in the first cell, and it is 0 in the last cell as well. So C's value is not changing. So we have to take the value of C here. Since C is 0, we can put C bar, right? And we can go for the next group, group 2, and this is the group 2. We can see here, this is the group 2, right? Group 2. Now you can see in this group 2, the value of A is 1 throughout this row, right? So you can simply put A, right? Now you can see, you can compare BC of this first cell with BC of the second cell. So B is shifting from first cell to second cell, and there is no change in value. B is 0, so we can simply put B bar. But if you see C, C is 0 here, and it is jumping, and it is joining here, right, like this. So C's value is changing from 0 to 1, so we should not take the value of C. So the answer is AB bar. So what is the sum of product form? You get sum of product form f of A, B, C is equal to A, B bar plus C bar, right? So this is what we get. This is not the actual thing we were solving in the class. We were solving this, and we wanted to check this one if this is actually working out with the other method. So the other method we were discussing was McCluskey method. So we are here to check whether we are getting the same result in McCluskey method as well. So we can highlight this. So we can solve the same problem using McCluskey. McCluskey method. Now we can start. So the given problem is f of ABC, that is equal to 0, 2, 4, 5, 6, right? So please write down this 0 in terms of 3-bit binary 0, 0, 0, and 2 in terms of 3-bit binary 0, 1, 0, and 4 in terms of 3-bit binary 1, 0, 0, and 5 as 1, 0, 1, and 6 as 1 1 0. Now we have to split them according to the number of zeros they have. So first things first, step 1. So step 1, see, count the number of zeros in the given problem. So who is having the maximum number of zeros? The number 0 is having the maximum number of zeros, 0 0 0. It has 3 zeros. So this becomes a group, and please select the digits that have 2 zeros. Number 2 has 2 zeros here, 0 1 0, and number 4 has 2 zeros, 1 0 0. And which is the digit that is having only 1 0? There are two digits that have only 1 0, 5 1 0 1, and the next one is 6 1 1 0. So the first group has 3 zeros, second group has 2 zeros, and the last group has only 1 0. So let's move on to the next step. So this is the step 2. Step 2, we need to compare the group 1, this is the group 1, group 2 and group 3, right? So how to group them? So we can go like this. For example, you can compare 0 with 2 and 4 and 5 and 6, right? But you cannot compare 4 with 0, right? And you cannot compare 2 with 0, and you cannot compare 5 with 0. You need to follow a top-down approach, alright? So also you cannot make groups within the group. You cannot compare 2 with 4, and you cannot compare 5 with 6, right? You should be remembering this when you are making the groupings. So if you are grouping, if you are trying to match 0 and 2, how to do that, right? So 0 and 2, if you take it for example 0 and 2, you should be looking for only one bit change. For example, if you are comparing 0 and 2, 0 and 1, I mean 0 and 0 common, 0 and 1, a bit is changing, 0 and 0, right? Please look for only one bit change, right? So since there are only one bit change, the middle bit is changing. The middle bit is the only difference between these two, 0 and 2. We can take them. So 0 dash 0, right? So this is the bit that was changing. Now we can compare 0 with 4. So if you compare 0 with 4, the first bit is changing, the rest of the two bits are the same. 0 and 1 changing, 0 0 0 0, both are same. So 0, 4, these two are a group now. Now since the first bit is changing, put a dash, 0 and 0, right? And you can compare 0 with 5. If you compare 0 with 5, the first bit 0, right, and the first bit of 5 is 1, changing, 0 0 common, 0 and 1. There are two bit changes, right? Since there are two bit changes, we cannot make them as a group, right? And you can compare 0 with 6. If you compare 0 with 6, the first two digits of 0 are 0 0, but the first two digits of 6 is 1 1. Since it is 1 1, there are two bit changes. Now we cannot make groups, right? Now we can try 2 with 5. If you compare 2 with 5, there will be two bit changes, right? This is a 1 bit, this is 1 bit, this is 1 bit. Now you can see 5, first bit is changing, second bit is changing, and third bit is also changing. 3 bits are all the bits are changing, so we cannot make group here. And you can compare 2 with 6. If you compare 2 with 6, what happens? The same thing is going to happen. 0 1, bit is changing, 1 1, there is no change, and last one is 0 and 0, right? So since the first bit is only changing, we can make 2 and 6 or a group. So since the first bit is changing, put a dash, and the rest of the digits are 1 and 0. Now we can try 4 with 5. Compare 4 with 5, right? If you compare 4 with 5, 1 1, no change, 0 0, no change, 0 1, there is a bit change. So it is 4 comma 5, that gives you 1 0 dash, right? Since the last bit is changing, we are putting a dash in the last bit. And we can compare 4 with 6. What happens? There is 1 1 0 1, this bit is changing 0 0, right? Since the middle bit is changing, we can put it as 4 comma 6, that is equal to 1 dash 0, right? So we have arrived to very near to the conclusion. Now we can go to the last step. So the last step goes like this. Can put a line for the last step. I'll write it in a different color. So last step, step number 3. Now you repeat what you actually did with the last step. The step 2. Now you compare 0 dash 0 with all the others, right? And you try to find out where is something that matches with the given bit. For example, if you compare 0 comma 2 with any other group, find if anything is identical. That means if there is anything that has only one bit change, right? If you compare 0 dash 0 with the 0 comma 4, this 0 and this is a dash, and this is a dash, this is a 0, so 2 bit changes, not possible. And we can compare 0 dash 0 with 2 comma 6, 0 dash bit change, dash 0 bit change, not possible. 0 comma 2 with 4 comma 5, if you try that, 0 1 dash 0 0 dash, all the 3 are changing, all 3 bits are changing, so it is not possible. Now you compare the last bit, 0 comma 2 4 comma 6, 0 1 bit change, dash dash no change, 0 0 no change. So we can come to the conclusion that 0 comma 2 and 4 comma 6 are a group. These 4 people are a group, they can form a group, right? So if you compare, if you can make a conclusion, which bit is changing? The first bit 0 1 is changing, so dash, already there is a dash, dash dash, there are 2 dashes, 0 0, right? Dash dash 0. So this is what we have concluded. And you can try to make pairs, we can try to make other groups as well. If I don't think there is no other possible groups available, we can make a try. For example, we can make 0 comma 4 2 comma 6, dash dash no change, dash 0 1 0 0, so dash dash 0, same thing is repeated, right? We can try other groups as well. For example, no, not possible. So since the same result is repeating, we can take this dash dash 0 as our conclusion. So we are given with 3 variables, A, B and C, right? Out of which A is dash, B is dash and C is dash, right? C is 0. So if C is 0, we can come to a conclusion that C bar is what we are getting, right? Now we can make a table like this. We can make a table 0 comma 2 comma 4 comma 6, right? This is the group. Which one in your given step 3 is given step 2 is left out? For example, you can try this 0 comma 2 in your problem. I'll make it in green color so that you can see, green color box. There is a 0 comma 2 in your step 2, yeah, you got it. And there is a 2 comma 4 in your step 2, 2 comma 4, there is no, yeah, please leave it. And there is a, I'll just make an undo here, and there is a 0 comma 4, yes, there is a 0 comma 4. There is a 2 comma 6, yes, there is a 2 comma 6. There is a 4 comma 5. Where is 4 comma 5? It is left out. Now you can see there is a 4 comma 6. There is a 4 comma 6. Which one is left out? 4 comma 5 is left out. This combination is not available. So if you put 4 comma 5 here, that gives you A, B bar, there is no C, right? A, B bar, there is no C. Now if you add these two sum of products, if you add these two, the answer will be A, B bar plus C bar, right? A, B bar plus C bar, and this is the same result we got using Kmap, right? Both the results are now the same and equal. So this is how you solve a problem using Kmap and McCluskey method. If you have any problems, if you have any doubts, please note it down and ask me in the class and let me explain you.